There's the lights on right there.
That doesn't mean it's recording.
Yeah, dude.
There's 8 boys. Let's see how many girls. Excuse me. 10, 11. I'm going to write that down. The ratio of boys to girls in this class is 8 to 11. Notice I expressed that as a fraction. Okay? That means for every 8 guys, there's 11 girls. Or, let me express that as a decimal. Check this out. Check this out. Let me get my calculator up here real quick. Let me take 8 divided by 11. 8 over 11. 8 divided by 11. What do I get? 0.727 second infinite decimal, but then it gets to a 3. It's kind of strange. I'm going to round the nearest tenth. That's about 0.7. So watch this. I'm going to express this very same ratio of boys to girls in this class as a decimal. I'm going to put approximately now 0.7. This is kind of clear. For every 8 guys in here, there's 11 girls. But this is really not so clear. But it's still the same ratio, though, in decimal form. Who can explain that to me? 0.7. Extra stamp. For every 8 guys in this class, Munguia's second period Math 3 class 2019, there's 11 girls. How would I express this in the same way? 0.7. You guys shut down. Once I put a decimal, you guys shut down. How about this? Work with me. What place is this as a decimal? What place is that? I have it on my poster over there. What place is it? The 10th place. So what this really means, you guys, this really means approximately 7/10. Which really means for every 7/10 of a boy, if I were to chop up the guys, like let's say just one guy, and chop you up into 10 pieces, it'd be a lot of blood and guts, but for every 7/10 of a guy, there's 1 girl in this class. That's the same way of saying for every 8 guys, there's 11 girls. This means for every 7/10 of a boy, so think of a boy in here and chop him up into 10 pieces, 10 equal pieces. If you take 7 of those pieces, for every 7 of those 7/10 of a piece of a boy, there's going to be 1 girl in here. This is really the same thing as saying this. It's just in decimal form. Every 7/10 of a guy, there's 1 girl, or every 8 guys, there's 11 girls. There's a comparison of numbers in here. Now, got the word ratio? Flip your page over again, decide what. And you'll see this picture at the bottom. Notice angle A here. What if a little arc here? Go to mark here. It's here a note, guys. It's for you. You're not going to turn this into me. It's for you. Could someone tell me how many degrees that angle is? Give me an extra stamp. Here, phone's out, by the way. I'd like to guess. That does look like a 45-degree angle. But we can get more exact if you pay close attention. How many degrees is that angle?
3.
You're on the right track.
42. 40.
Reyes, one more time. Look at tells you right here.
Come on.
Angle, look at BAC. That's this, look at BAC. That's that angle. Go to right 36.87 degrees.
That's tough.
So you're close, Rita. All right, now. Watch the magic. Go ahead and make little 90-degree angles here. These are all 90 degrees. Look at that. We start off with a small right triangle, and the right triangle keeps getting bigger and bigger and bigger. We end up having 8 right triangles there. They just keep getting bigger and bigger. Notice that. So far, so good.
Yeah.
So you're marking your paper with me. All right. You can see the 8 right triangles there, from biggest to smallest. That's pretty clear. Look what we're going to do now. We're going to take the ratio. We're going to start off with the big right triangle. Look at the biggest one. I'll highlight it in blue. You don't have the color, so don't worry about it. But I'm highlighting the big angle, the big triangle in blue. All right. And we're going to take the ratio. Remember, ratio, we just defined a comparison of 2 numbers. The ratio of the side that's opposite angle A, which is 36.87, the side that's opposite is BC. Look at it. Where's BC? Here's BC right here. The ratio of this side to the side that's touching angle A, which would be the side that's adjacent, which would be AC in this case. AC. So BC to AC, let's take the ratio of that. You're going to fill it in with me. So BC, it looks like BC, the side BC, looks like 6 to me. Look at it. Here's 6. BC looks like side a magnitude of 6 units. You want to put 6 there? How big is AC?
8.
Nice. Thank you, Flores. AC is 8. It's right there. Put it with me. There's the ratio. If I type that puppy in my calculator, 6 divided by 8, it ends up becoming 0.75. Believe it or not. No big deal. I'm going to write that there. Now let's tan A. Ignore that for now. I'm going to come back to that later. Tan A. I don't want to confuse you yet, give you nightmares yet. For now, all we're taking is ratios. I want you to see something. Look at now, KD. KD, we're talking about the next biggest triangle now. Look at KD is right here. Over AD, that's right there. So we're not the biggest triangle, not the next smaller one. But same side. Look at side opposite to that angle over side adjacent to that angle, the red angle. So let's see. KD, I want to say, it's a little bit past 5. Look at 5 is right here. I'm going to say 5.5. This is an estimate. 5.5. Right, that's KD. Over
7.
AD, what's
7.
AD?
7.
Rocket. 5.5 over 7. Fill that in with me. You're going to see something going on right now. Watch. Just stay with me. You might be asking, what is all this about? Be patient. Just stay with me. Follow me on this trail. Distinct the stop trail. 5.5 divided by 7 on a calculator, I end up getting 0.7 something, like 0.7 something. Just say 4 for now. I don't know. All I do know it's going to be very close to 0.75. Same ratio, in other words. Look at that. Keep following along. Be patient. Follow me on this trail. Next smallest triangle. LE. Okay. LE to AE. LE, I'd say, is about 4.75. 4.75. How about that? Sounds good to me. We're just estimating at this point. It's past 4. Look at LE. It's past 4. A little bit past halfway, I'd say. 4.75 divided by, what's AE? How big is AE?
6.
Thank you. 4.75 divided by 6. If I type that puppy in, where's my calculator?
I don't know, man.
4.75 divided by 6, I end up getting, watch this. Let me get my calculator. 4.75 divided by 6 is 0.79. Still close to 0.75, a little bit off, But you get the idea. It's still about the same ratio. I still keep getting this 0.7 something. It's a little bit off because I'm just eyeballing it. I'm just estimating from the picture. I'm not getting exact here. All right, that was the third largest. Let's go to the fourth largest triangle. MF.
3.5.
3.5. Looks a little bit larger than 3.5. I'm gonna go with 3.8. 3.5 is about right here. It's a little bit past 3. I'm going 3.8. Good estimate though. Over AF is 5. 3.8 divided by 5, ladies and gentlemen, is 0.76. You guys see something going on?
I don't see nothing. I ain't gonna lie to you.
There's a line of me.
I ain't gonna lie to you.
You're on YouTube right now saying that.
Okay.
It's gonna be okay. There we go. NG. NG over AG. So NG, I'm going to estimate NG to be 3. I think it's right smack dab, right there on 3. And then AG is 4. 3 divided by 4, that's a pretty easy one. That's 0.75. You see it, Flotus?
Yeah, I see it.
Over time? Yes. And they're all hovering around 0.75, huh? The 100th place. Okay, let's keep going. I want you to see something now. Watch. OH. OH, I want to say, is about 2.3, let's say. A little bit past 3. Or past 2, rather.
2.2.
All right. 2.3 divided by 3. Watch this. 2.3 divided by 3, about 0.76. Right, Varela? Give me a chance. Don't give up on me. We're almost done. 2 more to go, Varela. Watch. PI.
Like 1.5.
I like that one. 1.5 divided by what, Flores?
2.
2. Type that puppy in, you get 0.75 exactly.
I'm sure.
Let's see if someone can get the last one correctly, given our pattern. What would QJ be here? It's not exactly 1. What would that be?
1.5. 0.5.
Well, 1.5 is over here.
0.5. 0.5.
0.75. Look at 0.75 over AJ is 1. 0.75 over 1 is 0.75. Now watch this. Watch this. Every single one of these right triangles, all 8 of them, they shared an angle. They shared this angle that I asked in the beginning that Rios was actually estimating. They all shared this angle of 36.87 degrees. And no matter how big the triangle was or how small the triangle was, the ratio of the side that was opposite this angle, remember opposite the formula? This side's opposite this angle. The ratio of the side opposite to the side that's adjacent kept being
36.
this. It kept being 0.75. No matter how big the triangle was or how small the triangle was. Because this angle stayed the same. Now watch this. So write this down, just pay attention to something. I'm going to give you pearls here, watch. Watch. Let's say I'm standing right here. I'm seeing Ayala. There's me. Ayala's over there. Here's Ayala. And to the left of Ayala is Miss Horley. Watch. I'm standing here looking at Ayala. Let's say my angle from Ayala to Miss Horley is 36.87 degrees. Let's say it happens to be that. then I know the ratio between Ayala and Horley and Ayala and me is going to be 0.75. Now watch this. Just pay attention. Let's get a distance greater than Ayala. What about from me to, that's north. How about me to Mount Baldy? Mount Baldy is about behind him, but way, way behind him. Look at Mount Baldy. Let's say that's La Cañada, Flint Ridge in LA. What does it say LA? Right angle? So now I'm looking at Mount Baldy, same line of distance, same line of sight, same angle. So that's Mount Baldy. If I know the distance between me and Mount Baldy and the distance between Mount Baldy and LA, it's still going to be this ratio. How about this? Forget Mount Baldy. Let me start looking upwards. How about the moon? And then up here, how about Saturn? If the angle still is 36.87 degrees, then whatever object, let's say Saturn to the moon, and the moon to me, it's still going to be that ratio. Forget the moon. What's farther than the moon? Give me something. Pluto. Little Pluto. From me to Pluto, then Pluto to some other object, let's say some satellite, I don't know. If that angle stays 36.87 degrees, that ratio will still be 0.75. So the power in trigonometry is I can figure out any distance by triangulating, knowing that the ratio never changes for that angle. It's powerful, and it separates us from third world countries. Now, you don't know how to find the missing distances. That's where I'm taking you soon. But right now, you see something about a ratio that doesn't change and an angle that didn't change. Notice how the angle did not change. It stayed 36.87 degrees every single ratio we did. And the ratio stayed the same. For now, just soak that in. I'm not going to do any more math. Just soak in the fact that we have the same ratio and this angle did not change. It stayed 36.87 degrees. And these are all right angles, by the way, right?
Good.
Put your notes in your binder. Do not lose them. If I have to give you another one tomorrow, you're going to lose your stamp.
What?
For now, grab a Chromebook. You're going to do a grade check and a credit check. And then go on to your assignment. Garcia, give me one mic. Thank you.
Hey, mister, I need the assignment